Hi guys, happy Wednesday. This is the agenda for today. We're going to be learning how to write linear function rules given tables, domain, or range. Please feel free to pause the video or rewind as you need throughout the lesson in order to take your notes. And let's go ahead and get started. So for the first one, it says, when writing linear functions from a graph, we must find the slope and the y-intercept. Okay. The slope, we can refer to it as m, and the y-intercept as b, okay? This is how you will see it on the linear function notation. So different ways of writing slope, well, we have the rise over run. We have our formula, which is y2 minus y1 over x2 minus x1. And then we have the change of y over the change of x. And these you will use whenever you are given 2 points. All right. So the y-intercept is when x is equal to 0. Right? The x is equal to 0. It is also whenever the graph crosses the x-axis. Let's go ahead and work on some examples. All right. So for the first example, it says write linear function for the following tables. So in order to write the linear function, we're going to have to find two things. We said it was the slope and the y-intercept, right? So I'm going to start with the slope, which is y2 minus y1 over x2 minus x1. And I'm using this formula because I'm going to pick 2 points to be able to use this formula, all right? So let's go ahead and do that. It doesn't matter what 2 points you pick. I'm going to go ahead and pick this first point. Let me go ahead and redo that. I'm going to do this first point right here. And let's do this one over here. You can pick any 2 points. But you do have to make sure that the x and the y are together, okay? Now that we picked our 2 points, we can go ahead and label them. So this is our point 1. This is our point 2. So this is x1, y1. And this is x2. Whoops, that's a 2. y2. So now that I labeled my points, it's easier to plug it into the formula. So we have y2 minus y1. Well, the y2 is 10, so I'm going to have 10 minus y1 is negative 2. So I'm going to put that in parentheses, negative 2, because you don't want to forget about your negative. So every time you have a negative, make it a habit to put it inside of a parentheses. Now for the bottom part is x2 minus x1. So x2 is 1 minus x1, which is negative 2. So again, put it in parentheses since you have a negative. So now we need to evaluate this. So what is 10 minus negative 2? Well, if you put that in your calculator, or if you know how to work with negatives, you know that that's going to be 12 over what's 1 minus negative 2? Well, that's going to be positive 3. And then 12 divided by 3, well, that is 4. So we have that m is equal to 4. Now we need to find what b is. Our b is our y-intercept, okay? Remember, we said that the y-intercept is whenever the x whenever the x is equal to 0. So where is it equal to 0? Right here. Well, it's going to be right here, right? 0, 6. That means that our y-intercept is equal to 6. Y-intercept is equal to 6. So now that I have my slope and my y-intercept, I'm going to go ahead and write down my linear function notation, which looks like this. Y is equal to mx plus b. Now I can plug in everything that I found onto my equation. So I get that y is equal to m. M was 4, so 4x plus b. The b was the y-intercept, which we said it was positive 6, so that'd be plus 6. And that is how you write linear function. Now, for the second example, we have this graph, and if you notice, at the labels, we have the x and we have f of x. Okay, these two mean the same thing as these two. That we have our x here and our x here, and we have our y here, and f of x is the same thing as y. So I'm going to put is equal to y so that you don't get confused, okay? Don't let that just means that function of x. So now that we figured that out, we're going to go ahead and pick our 2 points. So I'm going to go ahead and pick this one, and I'll do the one below it. So this is 0.1, and this is 0.2. So then I have that I'm going to label it. So x1, y1, x2, y2. So now that I labeled my points, I can now plug it into the formula. So y2 minus y1, well, that is 0 minus 1 because y2 is 0 and y1 is 1. Over x2 minus x1, well, what is x2? x2 is 2 minus x1, which is 1. So what is 0 minus 1? Well, that is negative 1. Over, what's 2 minus 1? That's 1. And what is negative 1 over 1? Well, that is negative 1. So we get that m is equal to negative 1. Now we need to find our b, or our y-intercept. Well, where is the x equal to 0 here? It's right here, right? This point right here. That means that my y-intercept is equal to 2. So b is equal to 2. Now that I have my slope and my y-intercept, I'm going to go ahead and plug that into my linear function notation, which is y is equal to mx plus b. And I have y is equal to m as negative 1, right? So negative 1x plus b. Well, our y-intercept, we said it was positive 2, so it would be plus 2. And this is my final answer. All right, so for the following table, again, I'm going to go ahead and put that f of x is equal to y so that you guys don't get confused. And also so that you guys remember that the function of x is just the same thing as y. All right. So now that I have that, I'm going to write down my slope formula since that's the first thing I'm going to use. And now I can pick my 2 points, right? We need to find the slope and the y-intercept so that we can write our linear function. So I'm going to pick these 2 points. This one, and let's go ahead and do this one. So this is 0.1 and this is 0.2. I'm going to go ahead and label them. So this is x1, y1, x2, y2. All right, so 7.62 minus 2.54, because y2 minus y1, y2 is 7.62 and y1 is 2.54. Now for the bottom is x2 minus x1. Well, what is x2? x2 is 3 minus y1, or sorry, x1. x1 is 1, so 3 minus 1. So 7.62 minus 2.54. Well, that's going to be 5.08 over 3 minus 1. Well, that's just going to be 2. And then whenever you divide 5.08 divided by 2, you get 2.54. So we found that m is equal to 2.54. Now we need to find our b. So what is b? Well, b is whenever y is equal to, or sorry, x is equal to 0. And where do we find that x is equal to 0 here? Nowhere, right? So we're going to have to find b mathematically. So we're going to go ahead and find b by plugging in everything that we know. And we're going to use the linear function notation, which is y is equal to mx plus b. So I know what m is. I'm trying to find what b is. And this y right here and this x, That's a point, okay? I'm going to choose any of these points and plug my y value here and my x value here. So since I already picked my points here, I'm just going to go ahead and use this y1, okay? But really, you can use any of these 4 points. So let's go ahead and do that. For y, well, my y is 2.54, so I'm going to do 2.54 is equal to m. What is m? Well, we said it was 2.54. What is my x? My x is 1, so I'm going to put it in parentheses, plus b. And since I'm solving for b, I'm going to put a box around b so that I know that that's not going to be moved. So what is 2.54 times 1? Well, that's just 2.54. And I have my b again is equal to 2.54. I'm just bringing everything down. Now, that means that I need to move everything that's not in that box to the other side of the equation sign. So I'm going to have to move this 2.54 to the other side. So I'm going to do the opposite of positive 254, which is subtracting 2.54 on both sides. And this reduces to 0. This also reduces to 0. So that means that 0 is equal to b. Okay? And there is nothing wrong with getting that b is equal to 0. Okay? That just means that we go back to our linear function notation, which is the y is equal to mx plus b. And now we know what m is and we know what b is, so we can plug it in. So we get that y is equal to what we said m was 2.54, so we plug that in, and then we bring down our x, and then we just found b, right? We said that b was 0, so we do plus 0. And you can also rewrite this as y is equal to 2.54x. Since 0 doesn't really mean anything, you can leave it like this. And that would be your right answer. All right, for this next table, I'm going to go ahead and start with saying that f of x is equal to y. Whoops, let me go ahead and adjust that. So f of x is equal to y, right? So that we don't have any confusion there. Now I'm going to rewrite my slope formula, y2 minus y1 over x2 minus x1, because I'm going to be finding my slope and my y-intercept in order to write my linear function. So now that I did that, I'm going to go ahead and pick 2 points. Again, it can be any 2 points. I'm going to go ahead and pick that one, and let's do the last one. So this is my point 1, this is my point 2. Now I have to label them. So this is x1, y1, and this is x2, y2. All right, so now I can use my formula. So y2 minus y1, well, what is y2? It's going to be negative 5 minus y1, well, y1 is just 1 over x2. x2 is negative 4 minus x1. Well, x1 is negative 1. So put that in parentheses because it's a negative. So negative 5 minus 1, well, that's going to be negative 6 over negative 4 minus negative 1. Well, that's going to be negative 3. And then we have negative 6 divided by negative 3. Well, that's going to be positive 2. So we get that m is equal to 2. Now we have to find our b, okay? Our b is the same thing as the y-intercept, okay? Remember, it's the same thing as a y-intercept. So we said that the y-intercept is found by whenever x is equal to 0. So when is x equal to 0 here? Well, nowhere, right? So we have to find b. So remember how we did it in the last problem? We had to find b by using what we know. And we know our linear function notation, which is y is equal to mx plus b. And we know what m is. We are trying to find b. And actually, this y right here and this x is a point. It represents a point on this table. So we can pick any point on this table and plug it in. Since I already boxed in 2 points, I'm just going to go with 0.1 and I'm going to use that point. But really, you can use any point you'd like. All right, so the y for the 0.1, well, y1 is 1, so I'm just going to put 1, is equal to, what's m? M is 2. And then what is x? Well, x is -1 plus b. Put a box around b because that is what we're solving for. And now, what is 2 times -1? Well, 2 times -1 is just -2. And I'm going to bring everything else down, okay? Keep a box around your b. Now, I want to move that -2 to the other side of the equation sign so that I can get the b by itself. So I'm going to go ahead and add 2 since I'm doing the opposite of -2. So add 2 on both sides. We get 2 plus 1, well, that's 3. 3 is equal to b. Did I find b? Yes, I did. So now I can go back to my linear function notation, which is the y is equal to mx plus b. And I can plug in my m and my b now. So I have that y is equal to m, which is 2. And bring down your x, and then plus b. Well, the b we said was +3, so we do +3. And this is my final linear function. All right. So that's how you do it whenever you they don't give you the x is equal to 0. You have to find what the b is. If you have questions on any of these, please be sure to ask your teacher, okay?